at this. So basically, the way how to solve this is to write down how much money you make with each of those two strategies if you invest the same amount at the beginning. So you start off, say, with €1 here, and you invest that at the shorter spot rate, and then you reinvest that, what you have, at the forward rate. So maybe let's do the first part. Do some color coding here since I did this in 3 different colors. So if I start off, say, with €1 at the beginning, then I invest this at the short spot rate. How much do I get? Well, I get the amount that I invest plus, multiplied with 1 plus the spot rate here for 1 year. I'll do this here kind of a little bit more rigorously. So I put in the exponent here to remind you that these are annual rates. Since we only invest for 1 year here until T1 equals 1, we don't really have to keep track of it. And then the next one, I think I wrote this down in blue. So that will be the proceeds of the first investment that are now reinvested at the forward rate, which is unknown. So we just write down our formula for the forward rate. And again, that will be, maybe let me do it even more exhaustively here. So that will be the time difference, 2 minus 1. So it's the difference between the 2 points in time, T1 and T2, which is of course again exactly 1. And this strategy has to give the same result as an investment of €1 at the very long spot rate. So that was the spot rate for 2 years. And now we put it T2 equal to 2 years in the exponent. So this is called an implicit definition. That means we don't have a formula directly for the forward rate, but we have an equation that we can always set up, and then we can reverse, like back out what the missing forward rate is. Right. So now it's just basically rearranging the terms and solving for the forward rate. So our forward rate here, 1,2, is the longer rate that's on the right-hand side. So that's 1 plus the 2-year rate raised to the power of 2, divided by 1 plus the shorter rate minus 1. So with numbers, that's 1 plus 7.5% squared, divided by 1 plus 7.2% minus 1, and that gives us 9.2%.
Sorry, shouldn't it be 1 plus 7.2 or 1 plus 5.2? Because this is for year 3 and...
Oh, so yeah, so of course, yeah. I was just in the final result is correct, but here I messed up these numbers. So that's 7.2, and that is 5.2. Thank you. So this number here looks really, really high, but it is indeed the correct result. So you always have this result that the forward rate is very, very high if you have an increasing term structure. Right? So look at this. For 2 years, you're getting on average 7.2% every year. Now the first year gives you much less, so 2% less than this. So to compensate for that, the second year has to give you 2% more such that you get on average the same. Right? So here you get in the first rate 5.2, and then in the second year you get 9.2, and the average of the two will be 7.2. Unfortunately, directly averaging the rates does not work, so you always have to apply this formula here. But you can think of this as kind of, that's my average rate. So chaining the two rates has to give you the same outcome as the average long-term rate. So whenever you have an upward sloping term structure, your forward rates will be larger than the higher spot rate that you have. So it will always be above 9.2%. Conversely, if the term structure is decreasing, the rate here will be smaller than the smallest rate. Right, so that's a nice way of kind of checking whether you've done everything correct. So if you have an upward sloping term structure, your forward rate should be really high. And by the way, so there is a very nice data set. Maybe I can show it to you later from the German Bundesbank. They give you all the spot rates basically. I think I have a data set going back to 1972. And you can nicely use this, for example, for an empirical master thesis. And one of the things that you can do with this data set is to test an economic hypothesis around this, which is the so-called expectation hypothesis. So the expectation hypothesis says that the forward rate that you observe here, the 9.2%, should be a good estimator for future interest rates. Right? So if the theory is correct and you wait 1 year until the beginning of this, then the future spot rate at that new point in time, T1, should be equal to 9.2%, if the theory works. Unfortunately, this doesn't work in practice. It's a really bad estimator, to be honest, but it's something that you can actually directly test in the data. You compute the forward rates today, and then you just wait a year and see what is the spot rate that occurs, and then you compare the two. Right, you can run a regression, for example, that was pioneered again by Eugene Fama. So they're Fama-Bliss regressions. So you can test that, and what's very nice is you can even develop trading strategies around this using the products that we have here. Right, so because the expectation hypothesis usually does not work, you can actually create a profitable trade, but risky, it's not an arbitrage, a profitable risky strategy around this.